Hello, students. I got a couple other questions that came in on assessment 2.3, so homework 2.3. Question 1, 2, and I think it was 12. So 1, 2, and 12. So let's see, we'll start off with number 1. So let me jump in here, give ourselves a little white space. I may not do all the parts. The goal is that you understand the idea, and then you can do the parts. So let's see here. Taking a look at question number 1A. So it says, I wonder if I can zoom in on that. There we go. Then I'll just move my white space down over here and move this down over there. There we go. Okay. So it says we're trying to find the simplest possible expression for each of the following. So if you take a look, we've got the whole numbers. That's 0, 1, 2, 3, and so on. The natural numbers, which are 1, 2, 3, and so on. And then two additional sets. One of them is set A. And what we said in class is when you're kind of seeing a new set, if you are struggling with it, write out some of the numbers. So you know you're taking from the whole numbers. So take the first whole number, 0, plug it in, and you'd have 2 times 0 plus 1. So off to the side, I could write down what is that set equal to. This is what I probably do in my homework. So set A is 0 plus 1. So that's the number 1. Now come back and plug in the next number, which is 1. 2 times 1 is 2, plus 1 is 3. So the next number is 3 in my set. Plug in 2. 2 times 2 is 4, plus 1 is 5. So I get 5 in my set. And so on. Okay, so I kind of got the idea there. So A looks like it's the odd numbers, the odd whole numbers, I guess, which in this case will match up exactly with the odd natural numbers. And then go down and do the same thing for B. Yeah, just kind of jot down, see what's in B. So B says it's the set of all numbers x as long as x is equal to 2 times n, and n is a whole number. So put in the whole numbers, put in 0. 2 times 0 is 0. So put 0 in your set. 2 times 1 is 2, right? 2 times 2 is 4. 4 is 6, and we could go on and on and on. So now I've got A, B, W, and N. So I have 4 sets, and the question is asking me to write, the simplest way, to write W minus A. W set difference A is what I should say, because these are sets. Okay, so W is the whole number, so I have all the whole numbers here, and I want to take out everything that I just found in A. So if you're kind of going through and you're like, hey, what would that look like? Well, just, grab a little marker here and just kind of cross them off. So 0, that would stay, but 1 is gone. 2 would stay, but 3 is gone. 4 would stay, 5 is gone. And I'd keep going, taking everything that's in A out. And what would remain? So this is the question of the day, the question du jour. What would be remaining here? And if you took all of those out, hopefully you can see that what would be remaining is the even numbers. That's right. If you take the odd numbers out, you're left with the even numbers, and we have an expression for that, which is just B. So there you go. Part B says where do A and B intersect? I'm going to leave that one for you. Part C says where does W and N intersect? And again, looking at the two sets are listed right there on the screen. So if you start writing out where they intersect, that's perfectly fine. But then try to find the simplest expression. The simplest expression is not something typically that's a list of all the terms. You want to make it something a little bit more simple than that. Okay. Let's see here. I don't remember if I did this. I think I did number 3 as part of the homework questions. I think we did something like this in class, but let's see. I might as well. So again, not going to do all of them. There's 4 different parts, but your goal is to decide whether these are always equal. Now, they didn't tell me what A is. They didn't tell me what B is, but they just said, is A takeaway or set difference B the same as B set difference A? So I think I did this one in one of the videos for the homework. or just kind of going, I think it was the homework one. But yeah, so just try it, right? A set difference B and B set difference A. Now you have a couple ways you can go about trying it. You could try drawing a picture quickly if you wanted to. So you could say, okay, here's a picture. Here's set A. That's a horrible set A. Let's try that again. There's A, there's B. and I want A set difference B. So A set difference B, that's going to be red. That's everything that's in A, and then remove everything that's in B. Okay, so that would just be this chunk, kind of this moon shape, if you will. And then I would shade all of this. And again, I don't have my cool pen right here with me, so I'm just going to try to make this look like I've covered most of it. There we go. That's A set difference B. The other one is B set difference A. So that would be this one. Okay, so here's B, and B set difference A would be everything that's in B and take out what's also in A. So remove it all. So, all right, there we go. Okay, now you should ask yourself, are these always equal? uh, I mean, maybe, maybe, I don't know. I'd be trying to figure out if they're ever equal, but I don't see a way right off the bat. So I would need to find a counterexample. And so that just means looking at the picture, I need to find a set A and I need to find a set B, and probably easiest to find a set A that contains some things that definitely are not in B. 1, 2, 3, 4, and find a set B that definitely has some things that are not in A. So this could even be 3, 4, 5, 6, 7. Pi. I mean, I mean, it's a set of anything. It doesn't matter. And so just check yourself. Are these two equal? And if you take a look, A set difference B. So if I look at A and I do the set difference with B, I would remove what's in B. So A set difference B. I know some of you are still saying minus. It's not minus, because again, these are sets. So A set difference B would be 1, 2, and B set difference A, take out everything that's in A from B. And so then you would remove the 3 and the 4 that was in A, and that would leave you with the remaining pieces, which would be 5, 6. Oops. Let me start with 5, 6, 7, and pi. And now you could show that these two quantities, A set difference B and B set difference A, they are not equal in the situation you just gave. That is a counterexample, and you're ready to move on to the next one. You might be able to use the same set just to kind of get a feel for it here. But again, if you draw the picture, sometimes something like B, which we've talked about in class, would be very, very convenient because you might end up shading exactly the same image. And if you do shade exactly the same image, you might be able to say something like, hey, I think these are actually always equal. Let's see here. Last one, B union the empty set. I guess, I mean, just take a deep breath when you see it. Be like, okay, that looks complete, looks complicated, looks confusing, but really take a set and take the union of that with the empty set, right? What are you putting in? Are you bringing anything else to the table? Remember, the empty set is empty. There are no elements in it. So B union the empty set, I would write down B. That would be a simpler way to think about it. And I have to compare that with B intersect B. Okay, a set intersecting itself. That means I'm asking what elements are in B and also in B at the same time. And hopefully you come to the conclusion it's everything that's in B is in the intersection of B with itself. So this first one looks like B, the second one looks like B. That might give you a pretty good idea for your final answer. Let's see, let's take a look at 12 was the last question that came up in this set. So I'll white space this, we'll white space this. If n of A union B equals 23 and the intersection is 9, yeah, so this is actually what we did in class with the pieces. So we came up with the idea that n blue, let's see here, plus number of hexagons minus the number of blue and hexagon is equal to the number of blue or hexagon. Okay. And I just can't quickly type the union and intersection symbols if you really wanted those, and this would be oops, I don't know why I'm drawing in white font. This would be an intersection, and this over here would be the union. And if you remember, we did this because if you just count all the blues, you counted all the blue hexagons once. If you count all the hexagons separately, you counted the blue hexagons a second time. So we have to subtract the intersection to avoid double counting. And so that helps us get to what would be in A or B, what would be in at least one of those. So when you see these questions, all they're asking you to do is kind of put this information into what we came up with in groups. So I know that B could be A and B, doesn't matter. This says B and H, again, doesn't matter. Here B is 12 plus the number in A. Okay, we know we minus the number in the intersection, which is 9, and that's supposed to equal 23. So a little bit of algebra, you'd be good. Take 12, take away 9. 12 minus 9 should be 3. And then take away 3 from both sides, right? And there you go. Number in A is equal to 20. So that's it. Next, when they tell you how much is in A, how much is in B, how much is in the intersection, and you have to find the union. So once again, go back and use our handy little guide right there. And yeah, that always works. It always has to work, because if you were to build yourself a Venn diagram and then build yourself the two sets, any two sets, if you are trying to shade one of those sets, why don't I do yellow? That was strangely close. Why don't I just drag that down? So first I'll shade everything in yellow, yellow and blue. Why not blue? So I'll come over here. Oops. I need to go back to draw in blue. Okay, so here we go. And I'll draw that one like that. I guess that's pretty close. Maybe I can drag it over a little bit more. There we go. All right. So notice if you shade all of the yellow pieces, that means you're counting these two regions. If you shade all of the blue pieces, you'll be counting these two regions. And what hopefully you can notice is that you have now shaded the region in the middle twice. You've counted it twice. So what we need to do is go back and say, hey, I need to get rid of one of those. So I subtract it, and that's why we subtract one of them, so that each region in the union is counted exactly one time. And that is how you can do that problem. All right. That's it for this set. Hopefully that helps. And that's it. I'll see you soon. Off you go.